Professor Attia, hello, how are you?
Yes.
How well can you hear me?
I'm okay, and you? Yeah, I'm hearing you very well.
Thank you so much. It's an honor to have you. Thank you for taking your time. I think right now we're gonna make a brief interview. We have several questions to ask you, okay? Then probably if we have time, we will ask the audience to join the interview, okay?
Okay.
Сейчас немножко поговорим. Если у нас останется время, я думаю, мы дадим возможность аудитории тоже с экспертом пообщаться. I would really appreciate if you would sometimes stop and give me a little time to translate your answer. Is it okay?
Okay.
Okay, thank you so much. So the first question is, how do you think heterogeneous oil and gas bearing information should be managed?
Okay. Thank you very much. I would like to extend my sincere gratitude to the conference organizers, and I'm honored to be part of this event with all of you. Regarding this question, I saw this question is that's multi-layered question. So let me break it down step by step. Heterogeneous formation, heterogeneity is very important to know the oil-bearing formation status or gas-bearing formation status. I mean, is oil-bearing formation homogeneous or heterogeneous? Is gas-bearing formation homogeneous or heterogeneous? This is very important step.
Okay, thank you so much. То есть мы спросили эксперта, как, по его мнению, следует разрабатывать неоднородные пласты. Вот. Он, во-первых, нас очень благодарит, и он рад к нам присоединиться. И говорит о том, что очень важно в первую очередь выяснить статус залежей, как нефти, так и газосодержащих, и понять, насколько они однородны, либо неоднородны. Please go on. Thank you.
So this is very important step when we would like to start any improved oil recovery techniques or any improved oil recovery process. I mean, oil recovery means everything that will lead to enhanced oil production.
Okay. То есть особенно это важно. И, кстати говоря, это заглавная тема нашего интервью, это увеличение нефтеотдачи. И при применении любых методов нефтеотдачи это критически важная информация, которую мы в первую очередь должны оценить, это однородность пласта. Okay.
So the first step is very important to identify the reservoir homogeneity or heterogeneity.
Итак, это первый шаг – оценить однородность либо неоднородность. Okay, the second step.
So, in the first step, how can we know this reservoir homogeneous or heterogeneous? It's very important to get to know that during quick look. Quick look for what? For relation between porosity and permeability. If we found this relation is scattered, there is no relation, there is no good relation between them, that means our formation is heterogeneous.
Ну, то есть нам предлагают посмотреть на начальные данные, на кросс-плот пористость проницаемости. И если мы видим большой разброс, то вот понятно, что мы имеем дело с неоднородным пластом. Okay.
Another technique can be used to look quickly to know how to identify heterogeneity of formation, relation between water saturation and resistivity as well. If we found there is scatter, there is no good relation between them, that means our formation is heterogeneous.
Второй способ посмотреть также на корреляцию водонасыщенности и сопротивления. Опять же, если видим разброс, еще один способ понять, что у нас есть неоднородность. Okay.
There, another techniques also can be used to identify the rock heterogeneity, such as capillary pressure versus water saturation as well.
Excuse me, what versus water saturation?
Water saturation.
Versus
Capillary pressure.
Да, конечно. То есть глубина капиллярное давление против водонасыщенности. Thank you so much. Absolutely right.
Okay? The next step is if our reservoir, and we understand all of us, most of reservoir across the world are heterogeneous formation, so it's very important to know the degree of heterogeneity.
Почти все пласты так или иначе неоднородны, но нам нужно понять степень этой неоднородности. Right.
So how can we know the degree of heterogeneity? We can use two techniques, the Dijkstra-Parsons technique, in order to calculate the permeability variation, small v. This value of permeability variation range between 0 to 1. 0 means reservoir homogeneous, completely homogeneous. 1 means reservoir completely heterogeneous, which means complex lithology.
Я понял. Нам предлагают использовать критерий Dijkstra-Parsonsa, если я правильно услышал, и получить величину фактически от 0 до единицы, которая от 0 до единицы покажет нам полностью гомогенный, либо полностью неоднородный пласт. Thank you.
So after we understand, or after we calculate the degree of reservoir heterogeneity, oil-bearing formation or gas-bearing formation heterogeneity, as I mentioned, the permeability variation, or we can use also Lorentz coefficient to identify or to calculate the reservoir heterogeneity as well.
Okay. То есть, таким образом у нас есть несколько инструментов, с помощью которых мы неоднородность оцениваем перед тем, как заниматься improved oil recovery. Okay.
So after we calculate the degree of heterogeneity, so it's very important to divide this oil-bearing formation or gas-bearing formation, heterogeneous, I mean, it's very important to convert this formation to homogeneous zones.
Вот теперь нам нужно в неоднородном пласте выделить более-менее однородные зоны. Я вот так услышу эксперта. Thank you.
So we converted heterogeneous formation onto different zone. Each zone is similar in properties. I mean, each zone is homogeneous formation.
Okay. То есть у нас есть несколько зон, в каждой из которых мы считаем свойства более-менее постоянными и можем работать с ними, как будто они однородные. All right.
We have many techniques can be used to divide the heterogeneous formation onto zonations, each zone similar in properties.
Есть несколько техник, которые можно для этого использовать, для того, чтобы получить зоны с сходными свойствами.
It started by Amophil technique based on Cousine equation.
Артур Михайлович? Уравнение Казеня. Окей, первая техника. Thank you.
Okay, so keep in your mind the zones we have after converting the heterogeneous formation to zonations. This zone are not layers, are not layered or stratified. These zones dispersed in the oil-bearing formation or gas-bearing formation. So we can distinguish between each zone by color.
By what?
By color.
By color. Oh, yeah, okay. So we have something like a color map. Is it? Okay, то есть у нас в разрезе эти зоны, они не являются пластами. Это не пласты. Эти зоны разбросаны на самом деле в разных и нефти, и газосодержащих пластах. Какое слово, например? Scattered. Dispersed. Точно, да. Распределены по-разному в пластах. Okay, thank you.
So we have now zones, maybe we can say number of rock types.
Окей, теперь у нас есть число рок-типов. Very nice.
Okay?
Okay,
then we transferred heterogeneous formation, or we did formation to zone similar properties, each zone has between porosity and permeability.
Между порosностью и проницаемостью. Okay. Absolutely clear.
So each zone has a specific correlation, has specific correlation between Y and X, sometimes Y reservoir quality index versus normalized saturation, normalized porosity, or flow zone to get flow zone indicator.
Окей, то есть внутри каждой зоны у нас нормализованные корреляции совпадают. И мы можем считать эти зоны вот фактически рок-типами. Причем не обязательно пласты, это не обязательно одинаковая литология, это просто зоны, у которых вот эти свойства можно условно считать одинаковыми.
Ну, мы это называем петротипами.
Петротипами, да, рок-тип, окей. True. Thank you.
So finalize. We divided formation, heterogeneous formation onto zonation, and we get, which means we changing the scatter relation to be good relation between different layers in our different zones.
То есть таким образом у нас есть беспорядочное распределение на основе каких-то единичных свойств, которые мы, во-первых, сначала кластеризуем, чтобы уменьшить количество неопределенности. У нас будут теперь рок-типы. Эти рок-типы или петротипы мы распределяем, и внутри каждого из них у нас теперь есть свойства, которые мы считаем примерно совпадающими по всему разрезу, везде, где мы встречаем этот рок-тип. В любой скважине мы получается, скажем, процентное соотношение каждого типа. Okay, thank you so much. So that would be.
So the last step is after we classified, after we got the correlation, after we transfer from scatter to be oriented relation between them, directly we have to integrate what we reach with digital system with reservoir simulation.
Окей, ну последний шаг понятный. Теперь нам нужно внедрить эту классификацию в динамическую модель.
Распространить свойства.
Абсолютно, то есть распространить свойства. Окей.
So, in summary, I can say the answer focusing on number one, identifying or identification the heterogeneity of reservoir and the degree of it.
То есть в первую очередь оценить неоднородность и ее величину. Thank you.
Number two, quantifications. I mean the degree, how much of complex lithology we have.
Номер два – это ее оцифровать в количественном выражении. Okay?
Number three, how many zones we got due to divide or converting heterogeneous to be homogeneous. How many zones we have, how many rock type we have.
Okay, то есть третий шаг – это, собственно, кластеризация на количество типов необходимое, там, минимально возможно. And
then integration onto reservoir simulation, especially in a static model.
Распределение, собственно говоря, в численной модели для моделирования. Okay. So that is actually how we prepare the dynamic model to then, let's say, reproduce the effect of enhanced oil recovery. Is that correct? That would be the first step.
A static model describes all our formation, or oil-bearing formation, gas-bearing formation. Describe it based on seismic, based on geological data, based on petrophysical data, to build the static model. So if a static model cover oil-bearing formation, this formation we can divide it onto zonation. What I reach due to classified of heterogeneous formation onto zonation, I will apply it on the formation directly. No need to say initial condition, to assume initial and boundary condition in a static model. No need. You have to take what we reach due to transfer the heterogeneous formation onto many zonations or many zones.
Okay. То есть для того, чтобы корректно описать свойства пласта, нам совершенно не обязательно работать в начальном разрешении. И результаты кластеризации, финальные результаты обработки этой неоднородности позволят нам все равно корректно воспроизвести свойства пласта. Okay. Thank you.
So this is very important before we starting any improved air recovery to study reservoir characterization in term of heterogeneity or homogeneity.
Thank you. То есть прежде чем мы вообще начинаем думать о мунах, именно полномасштабных, которые вот называются enhanced oil recovery, нужно, конечно, в первую очередь заботиться о вопросе неоднородности и правильно ее воспроизвести. Okay.
Back to you.
Thank you.
Dr. Attia, this is
Yes.
Dr. Arthur with you. First of all, thank you very much for joining us in this event. It's one of the biggest forums in Russia, and it is the biggest in terms of in the context of the field development planning and well and reservoir management. So your participation give us quite an auditorium to communicate with you and to ask you questions, to get your responses from the, let's say, international perspectives. And what I would like personally is to ask you is a little bit broader than the specific questions on the geology and the modeling. So if I may, I would like to ask you this. Over the long period of time you've been engaged in the petroleum industry, I believe this is something like more than 30 years.
I'm sorry. I'm sorry.
Yeah. Sorry. During the last, let's say 20, 30 years of your engagement in petroleum industry, what do you think was the biggest breakthrough? What type of technology or the services which you never saw before, and then you saw it coming, and you believe it revolutionized the efficiency of the petroleum industry? Your opinion.
Okay, this is very important question. I went many places and I did a lot of work as a consultant with many companies. What I noticed, the very important, I'm talking about how to enhance oil production. So I found a lot of challenges in these techniques. I look thinking why the results is different than what we plan. I studied a lot and discussed with many people for this. Finally, I found no one starting to identify heterogeneity of formation. Because I mean heterogeneity, we cannot apply any equation. We have to produce equation after we divided this formation. You want me to stop and continue?
Yeah, this I understand. You believe that heterogeneity and the poor understanding of homogeneity or heterogeneity of the
100%.
rocks is the critical element of the successes or historical successes or historical failures. That's what
Yes.
I think, yes. This I totally agree with you.
Just a moment.
Yes.
Just a moment. То есть вопрос был о том, какой технологией является, по мнению эксперта, прорывной. Эксперт говорит, что при применении любой технологии, то, что он заметил, на самом деле успех или неудача во многом зависели от того, но он в основном занимался, как я понимаю, методами увеличения нефтеотдачи, и он говорит, что очень важно это именно то, что люди неправильно определяют неоднородность пласта. Thank you.
But still, my question to you, let it be the studying heterogeneity or inheterogeneity, let it be that subject. But what do you believe in the last 30 years has been achieved like a breakthrough? What do you believe was a big breakthrough in this area?
The big breakthrough using nanotechnology to enhance oil production.
What
Using
else?
nanotechnology.
Software, hardware, methodological, any
Okay.
experience of the knowledge which
Excellent.
become revolutionizing. Yeah.
Okay, thank you. First of all, regarding to identify the reservoir very well, it's very important to have more accurate apparatus or devices or equipment such as NMR in order to get accurate results, in order to calculate or to identify the reservoir heterogeneity, and then you apply any technique. So NMR is number one, and any equipment can be used to enhance or to get more accurate rock and fluid properties. I advise to you that. This is number two. Number three, from my experience, we cannot make a decision in oil and gas field by one tool. So we have to use many tools to confirm each other in order to take the decision.
In other,
Я так понимаю, критерии успеха на самом деле перечисляет эксперт, да? То есть, что я услышал, это то, что, ну, окей, начнем с конца. Во-первых, любые свойства определяем с нескольких сторон, несколькими инструментами. Во-вторых, повышаем точность разрешающую способность любого измерительного оборудования. А вот первое, там была аббревиатура?
Mapping.
Mapping.
Да, ну, то есть софты.
Окей, софты.
4D seismic, we have to use 4D seismic.
4D seismic.
4D seismic.
So basically, you saw, I believe, a big improvement in open hole logging tools, more sensors, higher quality of the sensors, the number of different type of sensors which are sensitive to lithofaces, which help us to understand heterogeneity.
Exactly.
Plus, you say that the 4D seismic is a revolution. 4D seismic.
Yes.
Which can actually track the movement of water and migration of water over time. That's
exactly.
It helps calibrating the dynamic model and identifying the distribution of the faces over the 3D space.
Yes, exactly.
Okay.
So I agree with you 100%. If we use what you mentioned, sensors, if we use new technology as an MR or others to calculate or to get oil and gas and formation properties, then we're going in the right way to decrease the water cut to enhance the efficiency oil production.
Так получилось не специально, но эксперт, которого мы пригласили, он просто очень любит работать с данными, с петрофизикой. Он очень хочет все сначала точно померить, происследовать и считает, что в этом ключ к успеху.
Why I was asking this, Dr. Attia, is because that sometimes our experts at the forum over the years, answering the same question, they don't put a lot of focus on the software. Or understanding the reserves, assuming that the reserves will flow to the well no matter where you put that well, yeah? And it's much more important, the drilling advantages, the horizontalizing, the hydrofracturing. So basically the contact between the well and the reservoir is more important than understanding of the reservoir. And there are expert opinions on this. So basically what you're saying here is that, no, I would put the understanding of the reserves at the first place rather than focusing on the way you are trying to extract those reserves.
At the beginning, I said we have to understand the oil-bearing formation or gas-bearing formation very well using new technology.
Yeah.
Absolutely. Okay. And I think we would have still time for one last question, okay?
We have already, if we talk about the oil recovery, we have two techniques, conventional and unconventional. So conventional, I mean primary recovery or secondary recovery. Primary recovery is a conventional technique which based on our oil production, based on the natural forces, internal natural forces existing in the reservoir. So the reservoir drive mechanism in primary recovery are such as bottom water drive or edge water drive, gas in solution, gas cap, combination, or gravity. This is for oil reservoirs. For gas reservoirs, natural forces inside gas reservoirs, we have only two reservoir drive mechanisms: bottom water drive and volumetric, which means gas expansion. So based on the internal forces inside the reservoir, we produce more oil from subsurface to surface. The oil recovery by this stage, about 10 to 15% from initial oil in place. And then due to reduction of pressure, we moved to secondary stage, which is called secondary recovery. It's based on gas injection or water injection or water flooding.
Окей. Ну, то есть у нас есть традиционно, нетрадиционно. Ну, вот conventional сложно сказать, как это точно перевести в этом контексте, потому что conventional эксперт относит на самом деле естественные силы в пласте. Это аквифер, газовая шапка и просто естественное расширение. То есть, ну, фактически это вот наши базовые механизмы извлечения в отсутствие специально созданных на энергии пласта. Ну, в газе там только две силы, да, у нас там может быть либо вода, либо расширение, да, либо и то, и другое. Окей.
So secondary flooding or secondary recovery, it's repressurizing, raise the reservoir pressure, maintain reservoir pressure in order to continue, which means we use external forces to support internal forces.
Absolutely. Ну и вторичные методы — это закачка. Absolutely.
Okay, then we'll move to enhanced oil recovery techniques, chemical methods. We can use polymer flooding, alkaline flooding, surfactant flooding, alkaline surfactant polymer. I can use also viscoelastic surfactant. I can use thermal techniques such as hot water, steam injection, in situ combustion. It's based on the oil and reservoir condition.
Ну, дальше у нас начинаются третичные методы, и тут эксперт перечислил множество технологий. Это закачка полимеров, щелочи, АСП, это термические методы, это методы там, внутрипластового горения и так далее. Okay.
And then we have also carbon dioxide technique, which is very important in order to reduce the greenhouse gas emission. You can use carbon dioxide re-injection onto reservoir in two ways. I can use it as secondary flooding, immiscible flooding. I can use it as an enhanced oil recovery technique, which is miscible flooding.
Okay. Ну и еще одна техника — это обратная закачка газа, которую можно в разных режимах использовать, смешивающееся, не смешивающее вытеснение. Okay.
This is in addition, we can use microbial enhanced oil recovery as well, indigenous bacteria.
Okay. Вот огромный набор методов, которые можно использовать для дополнительного извлечения нефти. Okay.
So, if you look for chemical methods, polymer, the main function of using polymer is to enhance sweep efficiency.
Ну, главное преимущество полимера — нам нужно увеличить коэффициент вытеснения.
Regarding alkaline, you know alkaline will react with organic acid in crude oil to form soap.
Щелочь.
Alkaline will react with organic acid existing in crude oil to form soap or emulsion.
Вот алкайны взаимодействуют с кислотой, которая уже присутствует в нефти, и формирует, вот, по сути дела, мыльную пленку.
Okay. Yeah, okay, thank you so much.
So, based on this alkaline react with organic acid to form emulsion, which means surface active material in situ, to reduce the interfacial tension. So the main function of alkaline to change or to reduce interfacial tension between oil and gas, between oil and water, and also to change the rock wettability from oil wet to water wet, or from weak water wet to strongly water wet.
Okay. Ну, то есть получается, что по результатам этой закачки мы можем получить фактически изменение свойств пласта, смачиваемости, и получить фактически там из гидрофобного
Сменить смачиваемость.
Да, гидрофильный, да, и наоборот. Да. Okay, thank you. Professor Attia.
Yes.
Unfortunately, the time for our interview has come to an end, and I would like to express a sincere gratitude. Thank you so much for joining us. Thank you for being with us. Thank you for your answers. And we need to go on. And we'll contact you later. Thank you so much.
And we
You're
hope to
welcome.
see you one day visiting a forum in Russia, in one of the cities.
In person.
In
We'll be
person.
happy. We'll be happy if you invite me. We'll be happy طبعا to come to you. I really enjoyed our discussion. It was يعني very fruitful session, and really I would like to give you a lot and hear also from you a lot. So thank you very much for this, and I look forward to meet you in Moscow, and also I invite you to meet me in British University in Egypt as well.
Thank you.
Very much. Thank you. Thank you.
You're welcome.